exponential function of a complex variable. So we define if z is a complex number x plus iy, where x and y are reals, x and y are reals, then we define e to the power z equal to e to the power x plus cos y plus I sin y. That is the definition of an exponential function of a complex number. Now we have some special condition. Say z is equal to x, that is purely real. Then e to the power z will be e to the power x. Similarly, if z is iy, purely imaginary, then e to the power z is equal to e to the power iy. Then since x is 0 here, we put x is 0 here, so it is cos y plus I sin y. This is the condition when z is purely real. Then we have, since e to the power x greater than 0 for any x, for all x, so e to the power x cos y plus I sin y represents the polar form of e to the power z. Polar form of e to the power z. So represent a polar form, because in case of complex number, if we have a complex number z, then we represent a complex number in polar form in this way, where R is real and positive, and theta is a real number. Here also we have y and x real, e to the power x is positive. So this representation means it is a polar form of e to the power z. Next, now e to the power x not equal to 0 for all x. E to the power x not equal to 0 for all x. So e to the power z not equal to 0 for all non-zero x z. E to the power z also non-zero. Similarly, if we have a non-zero complex number, if I have non-zero complex number u plus ib, then we have polar form of u plus ib. Polar form of u plus ib is the, say, r cos theta plus I sin theta. Since it is non-zero, so r greater than 0, so r can be expressed e to the power log r, because r greater than 0 means log r is real, and you can express r in this way, e to the power log r. So u plus ib can be written as, instead of r you put e to the power log r and cos theta plus I sin theta. Now cos theta plus I sin theta is e to the power I theta. So exponential function in case of exponential we can write in this way. So this is a complex number z. So given a non-zero complex number u plus ib, you will get a complex number z such that u plus ib equal to e to the power z. So for any complex number non-zero, you will get a complex number z such that e to the power z equal to ib. Next we have suppose n is a natural integer, then e to the power z same as e to the power z plus twice n pi, since twice n pi equal to 1. So this represents e to the power z is a periodic function with period twice pi, with period twice pi I. Then some properties we consider e to the power z1 into e to the power z2, z1 plus z2, then e to the power z1 by e to the power z2, e to the power z1 by minus z2. Number 3, e to the power z to the power n, nz, n is a integer. Now if n is a fraction, say n equal to p by q, then e to the power z to the power n is nothing but p by q. So has q distinct values, where e to the power nz is unique and is one of the values of e to the power n z to the power n. One of the values. Out of two values, this is one of the values. So these are some basic properties of exponential function of complex number. Now we have some examples. Say find all the values of z such that e to the power z equal to 1. We have to find the values of z such that e to the power z equal to 1. So first of all, z is equal to x plus iy. So e to the power z is e to the power x cos y plus I sin y. Now 1 means 1 plus I0. So e to the power x cos y equal to 1 and e to the power x sin y equal to 0. Since 1 is 1 plus I. So solving these two, you will get equal to x1 and this implies x equal to 0. And if x equal to 0 put here, you will get cos y equal to 1, sin y equal to 0. So from this y will be y is n pi, n is an integer. So now z, we suppose z is x plus I, right? So what will be the z? Values of z? X, 0, I, y and y. So this is y and y. So in this way you can say another example. So e to the power z equal to 1 plus different complex number 1 plus root 3. Same process, you will get this one. Now here it is x cos y will be 1, e to the power x sin y will be root 3. So solving this, you will get this square plus this square 4, 2, and from this you will get cos y equal to half, sin y equal to root 3 by 2. So solving these two, y will be y and pi root 5 by 3, and it is integer. This is from general values of it's a general solution of trigonometric equation. So you will get y equal to twice tan pi plus pi by 3. So x is z is equal to x plus iy. We suppose that. So x is given by, from this you will get x is log of 2. So it is log of 2 plus I y sin y plus pi by n is a integer. So this is the values of, you sense n, you will get different values of z, so that equilibrium z is given by this. Thank you.